Suppose you already know what is the value of this dx, and you want to find out from 0 to L what is exactly the whole length of the rod. So in that case, what you can do, you can just simply integrate it from 0 to L. So in integration, there is a step for the limits, writing of the limits and all. So the best part about integration is that when you know a small thing, a small quantity, or any quantity, and you want to expand it. Now, how can you expand it? Using limits. You set the limits and it will be done. Now, I'll show you how will it be done. A few examples from your chapter. See, one more thing you should remember regarding integration. Remember, integration is just the inverse operation of differentiation. This is the inverse operation of differentiation. It means, see, your addition and subtraction are inverse operation. If I have 5 plus 3 as 8, then when I bring this 3 on the other side, 8 minus 3 will give this 5 back. They are inverse operation, addition and subtraction. Or your multiplication and division. If I have 6 by 3 is 2, so when I bring it here, 3 into 2 will give me 6 back. So similarly, differentiation and integration are also like this. If you have differentiated something, you reverse it, you will use integration, you will get the quantity back. Now, what are the applications? Basically, in the application, see, velocity, we will see in the chapter, it is dx over dt. Okay, this is the formula of velocity, dx over dt. We will see also, and we have seen it in the examples of differentiation also. See, when I want to get velocity, I'll differentiate the position. But if I want to get the position, I will integrate velocity like this. Dx will be v dt. This is how you will calculate the displacement. Next is like the change in velocity. See, again, acceleration is what? Acceleration is dv over dt. Means you are differentiating with respect to time, velocity with respect to time. But Safa, if you want the acceleration, you can differentiate. But if you want the velocity, you can simply integrate. That's all the application that will be used, and many more applications are there, and its applications are endless. They'll be there in your class 12th also. The lessons will be there also, so you have to include it there. And whatever integration, differentiation and vectors that you're studying in class 11, this is not just for class 11, it will be for your 12th board exams also. Okay, those are also in your target, right? But right now you should just focus on class 11 part. Now let me tell you how we actually write a polynomial function. See, let's say you are given some y is equal to x to the power n. Now this won't be just given. You will have the limits also. Let's say from x1 to x2. See, this is the lower limit. This is the lower limit. And this is the upper limit in integration. This is the lower limit, this is the upper limit, and this is the symbol for integration. Like differentiation, we have studied x to the power n is there. And how do we differentiate it? N x to the power n minus 1. Here the formula will be different. One thing is there, some things are new here, x1 to x2. What are you doing here in integration? Basically, you are expanding on things. Like, you know, a very small quantity dx, and you are integrating it, means you are expanding it. In differentiation, we had a bigger thing and we just wanted the smaller one. Here you are having a small thing and you are expanding it. So we'll put the limits from where do you want to expand. Like if I have a time, I want to expand, I want to get velocity for 2 to 8 seconds. So I'll set the limits as 2 to 8 seconds. That's why you have the significance of limits here. Okay. And as I discussed in the example, keep this also in mind. When velocity is differentiation of position with respect to time, If you want to get velocity, if you want to get position from this, you will integrate it like this. Or if you have acceleration equation, A is dv over dt. For differentiation, it will give you acceleration. But what if you want this velocity? So you can integrate acceleration. Means it's just the reverse. 6 by 3 is 2. 2 into 3 will give you 6 back. Something like that. Inverse operation. Okay. So this is how you will find symbol. And this symbol, this sigmoid symbol will be present everywhere. Now let's see how we actually integrate it. I'll just tell you the formula, then examples, through examples only it will get clear. So don't get scared of the formula because it's a little, it has one more step than the differentiation. See, when we are integrating y, x to the power n is there. In the differentiation, this used to become n minus 1, the power. Here,
Yes,
there
ma'am.
are any n getting multiplied, power will be added to 1. X to the power n plus 1. Plus 1 is here. And what is this power n plus 1? You divide it by the same. X to the power n plus 1, you divide it by n plus 1. What are the limits? Let's say some x1 to x2 are there. With the example only, Safa, it will be clear. Just have a little patience. This is the first step. Second step is
Yes,
that
ma'am.
in differentiation, in one step only, we used to get our answer because there was
Yes,
no
ma'am.
concept of limits, right? Nx to the power n minus 1, answer aa gaya. X square 2x, x cube 3x square, 4x cube 12x square. Like this, you will get the answers in one line. Here, the problem
Yes,
is that there are limits. Time will be given, position will be given, anything can be given to you. So, what do we do? In the next step, you keep your n plus 1 as it is. Don't disturb it. Whatever is it, it will act as a constant and will always be a constant. 2, 3, whatever is it, just put it here. Instead of this x, you put this upper limit first. Okay, upper limit will come first. I'm writing upper limit only, then I'll put x2. Upper limit, what was the power of here? N plus 1. Means you're just removing the x and sliding your x2 first. You're putting your upper limit.
yes, ma'am.
Then you put a negative sign, subtract the lower limit to the same power. That's it. This is done. Let's look
Yes,
at through one or two examples. It will be clear. Let's say you have a function y is equal to x square dx. Okay. So when you are integrating, see how will you integrate it? Look, first step is first step is x square is there. Now you have the power as this is your n now, x square. Like in differentiation also this used to be our power. So this
yes, ma'am.
will be 2 plus 1, right? X to the power
Yes,
n plus 1. Okay, this is x to the power n plus 1. And for denominator, what do? We write it with the same thing. X to the power n plus 1 is here. We'll write it with 2 plus 1 only. And put the limits as it is. Don't insert them. So it's better if we know what is 2 plus 1 right now. Like n plus 1 wasn't known, but 2 plus 1, it's 3. So this time it
yes,
will
ma'am.
be x cube divided by 3 from 3 to 4. This we have just done the first step. This step has been done. X cube we have just calculated. N was 2, so we have calculated. Now what are we going to do? Instead of this x, put the upper limit. So 4 cube minus, what's the lower limit? 3 cube divided by 3. That's how we write. Now see, your powers x, y, z, everything is eliminated itself here. You'll not get
Yes, ma'am.
any x, y, z. In differentiation, we used to have it. In integration, you'll get a finite value. Okay, one single
Yes,
finite
ma'am.
value will be present. So then you can solve this further also. This is 64 minus 9 by 3, which will be 55 by, no, 55. This will be 50, 64 and 956 by 3. Okay, now I'm leaving the answer here because you don't need to write the answers in decimals and all. Just keep your answers till here because your purpose is not to solve these. You have to write it till here. So, Safa, write down everything about integration first, copy it, have it. And if you have any doubts in between, please ask. We'll see more examples. Lots of things are there to be discussed. Okay?
Yes, ma'am.
Is everything clear properly till here?
Yes, ma'am.
All right. Please write it. Just text me a done in the chat box. I'll scroll down the page.
Yes, ma'am.
Okay, look, Papa, let's see this question. P cube dt. One thing remember always in integration. If you are given a function like this, v, let's say velocity is there, and you are asked to differentiate, let's say v dt is there, and the limits of v1 and v2 are given. This is not possible. Okay, this is not possible. You need to have the same limits. So it means there is some more thing present in the question which it wants you to write it, that we'll see through the help of questions. Now, T3 is there. That will be 3 plus 1 divided by 3 plus 1 from 0 to 2. So this becomes T to the power 4 divided by 4 from 0 to 2. Now we will put 2 in place of T. That becomes 2 to the power 4 minus 0 to the power 4 divided by 4, which is 16 by 4. That is 4. This is the answer. Okay, now Safa, what you do? A few questions, these two questions you try at least, then I'll discuss their answers. Okay, but first write down this one.
Uh, Ma'am, but why do we need limits? Like, what do the limits represent?
Limits are representing this quantity, what you are integrating. Like if I'm putting 0 to 2, this means 0 second to 2 second. Like this, they are just representing the quantity. Like I want the acceleration for 4 meter to 8 meter. So I'll put the
Yes, ma'am.
limit as 4 to 8 like this. In the applications we will see in the chapter, integration is used itself. Okay. So limits are basically representing this quantity, what you are integrating. Okay.
Oh, okay, ma'am. Yes, ma'am.
Safa, did you get the answer?
No, ma'am. it 81 by 4?
You're getting 81 by 4?
Yes, ma'am.
Yes, correct. This is right. Very good, Safa. So you've understood it. Let me do this for you. Then the next one you all tell me. You tell me.
Yes, ma'am.
See, y to the power 4 and dy is there. So we are integrating y. So see, all these things will be representing one or the other things. So when we have y to the power 4 plus 1 divided by 4 plus 1 from 0 to 1. That is y to the power 5 divided by 5 from 0 to 1. Now 1 to the power 5 minus 0 to the power 5 by 5. Answer is 1 by 5. Got it?
Ma'am, so these in the third step, these 1 and 0 don't represent the exponents, right? It's just the limit.
Yeah, these are not the exponent. Only the exponential term that you will have will be this. That's it. These
Yes,
are
ma'am.
just the values which are actually having a meaning. Like right now, we are just initially practicing how to integrate and how to differentiate. We are not seeing the application part. But when you will have
Yes,
the chapter, I'll just give you a very small example so a little clarity is there. Suppose you have velocity's equation as 3t square plus 2t like this. And displacement is asked between 0 to 4 seconds like this. Suppose a question is there, v is 3t square plus 2t, displacement is asked. Now see, there is a difference. When you had, if this equation was of position, you would have just differentiated it and you would have put the limit and just the values of time and you would have got the value. Right now it's
yes,
opposite. So what we'll do, we will now write it as v dt and this equation we'll write here, and when we'll integrate it, no, there we'll put these limits because these are representing the time and all these functions are for time. Got it?
yes, ma'am.
Okay. Safa, just copy down this example and then the next one you at least try. Okay, few examples.
Yes,
Try.
ma'am. Done, ma'am. Ma'am, I got 4 to the power 3 by 2 by 3 by 2.
Let me write it. What is the answer? 4 to the power
4 to the power 3 by 2
hmm,
by 3 by 2.
by 3 by 2. This is the answer.
Yes, ma'am.
Let me check. See, we'll have t to the power half plus 1 divided by half plus 1 from 0 to 4. So this is right. T to the power 3 by 2 will come. Here 3 by 2 will come. And limits will be from 0 to 4. Correct? 4 to the
Yes,
power
ma'am.
3 by 2 minus 0 to the power 3 by 2, right? Divided by 3 by 2. Okay. See, Safa, just one or two things. Till here, your answer is absolutely right, but you can write a little it. You can write it in a better way, as in this 3 by 2 is here. Shift 2 up, so it will be 2 by 3 like this, right? Into 4
Yes,
to the
ma'am.
power 3 by 2. Because right now you have 2 by 3, 3 by 2. Sometimes it can get cancelled or something. And one more thing, when you have to answer 4 to the power 3 by 2, no, answer it like this: 4 to the power half, 2 the
Yes,
power
ma'am.
3. See, when this is the case, powers of powers. These are not limits now, these are the powers. When you have powers of powers, you multiply them. So we'll get 3 by 2 back. It means it can be written like this.
Yes, ma'am.
So 4 to the power half is what?
Root 4.
4. That is 2. It will
Yes,
become
ma'am.
2. So this is nothing but 2 cube. 4 to the power this. So 2 to the power 4 by 3, because this 2 will also be multiplied. 16
Yes,
by.
ma'am.
Got it?
Yes, ma'am.
Okay, just write one or two lines. This part I'm discussing, these two you will then tell me. Just
Yes.
wait, let me discuss this, then you can write. See, when you have x to the power 3 by 2, again it will be 3 by 2 plus 1 divided by 3 by 2 plus 1, because fractions can be there. So we have to be prepared with the toughest part, right? And see, these integration and differentiation that we are discussing in the class, maximum portion will cover your entire 11th and 12th. You don't need anything else to study here in these. Okay, these are stuff which just keep on practicing them. And Safa, you share your assignment. I've given you an
Yes, ma'am.
assignment based on
Uh,
this.
Actually, I contacted the team and there's some difficulty in opening the website. Like, I'm not getting the OTP back on my mom's WhatsApp. So, I don't know why.
Okay, I'll just talk. Okay, Safa, you should have told me before. I'll just talk to them. I'll get it clear. I thought you have received the assignment. I just
No,
wait.
ma'am.
Okay, okay. No worries then. X to the power 5 by 2 divided by 5 by 2 from 0 to 1. Now, see, I can write this as 2 by 5, and this will be 1 to the power 5 by 2 minus 0 to the power 5 by 2, which is nothing but 2 by 5. So this
Yes,
is
ma'am.
how you have to deal with fractions. So these two parts you will tell me, that will give you a thorough explanation. Just add down the things here. I think this page is sufficient. Just write this one and then this one.
Yes, ma'am. Ma'am, why did we cancel 1 to the power 5 by 2 minus 0 to the power 5 by 2?
Cancel it. Actually, 1 to the power, 1 raised to power any exponent is actually 1. So 1 minus 0 is 1, and 1 multiplied to 2 by 5 is 5, is 2 by 5.
Yes, ma'am.
So 1 to the power x, y, z, whatever you get, it will always be a 1. Okay?
Yes, ma'am. Yes, ma'am.
See, Safa, let's discuss this. B to the power, this will be 3 by 2 plus 1 divided by 3 by 2 plus 1 from 2 to 0. Now, 3 by 2 plus 1 is, what is it?
Uh,
Yeah,
but
5 by 2. 5 by 2, no?
yes, ma'am.
So this is 5 by 2. Here we will get a 5 by 2 from 0 to, from 2 to 0. See, 0 to the power 5 by 2 minus 2 to the power 5 by 2 divided by 5 by 2. Answer will be 2 by 5 into 2 to the power 5 by 2. Later on you can solve these. Bases are same, so see powers will get added up, right?
Yes, ma'am.
So this will be 1 plus 5 by 2. That is 2 to the power 7 by 2 by 5. See, when bases, when you shift this to, that's why I'm saying whenever you have, when you are done with this step, shift this. Many a times it can get cancelled. Many a times it will help you solve other things. This 2 to the power
Yes,
5
ma'am.
by 2 is there with a negative sign. Minus is there. So, and there, this you have 2 to the power 1. Bases are same, powers get added up. That's how you just simplify it.
Yes,
This much answer is sufficient. Okay. Let's come to the next one. Now you tell me the steps of a. At least you must have done it.
yes, ma'am. X to the power 7 plus 1
Yes.
divided by 7 plus 1, and then upper limit is 4 and lower limit is 3.
Yes, right. Then we'll put 4. See, that will become 8. So 4 to the power 8 minus 3 to the power 8 divided by 8. Okay, this you can solve later. It will be a bigger value. All right. So just write down
Yes,
what all things you have not written. And this one is very easy. I'll discuss this with you. First, you write it.
yes, ma'am. Could you please scroll up for a minute?
Safa, have you written it till here? These many parts?
Yes, ma'am.
Okay. Let's discuss some more examples. See, now this you will find it a little easier because you have dealt with fractions. So after fractions, these simple numbers without fractions look similar. See, x to the power 2. It will be, what will be the power?
X to the power 3.
3. Exactly, 2 plus 1. But write down each and every step, okay? Because
Yes.
integration cannot be done without the steps, without writing, because there are various things, no? Power substitution and all. So
Yes,
this
ma'am.
becomes x cube by 3 from 2 to 4. This becomes 4 to the power 3 minus 2 to the power 3 divided by 3. Okay. This will be 64 minus 8 divided by 3. See, one more thing, Safa. You will get the values, and when once you are getting the final answer, okay, whatever answer you are putting it, always try to put the units also. Like right now, we are just solving random questions, right? Random values. These are not even actual functions. So when you're solving, put in the final unit as your answer.
Yes, ma'am.
All right. Okay.
Yes, ma'am.
So this is 56 by 3, and that's the answer. Now, talking about this will be t to the power 7 by 7, right? I'll just write the previous
Yes,
step.
ma'am.
It will be 6 plus 1 divided by 6 plus 1 from 0 to 1. So see, when we put the upper limit 1 to the power 7 minus 0 to the power 7 by 7, see 1 to the power 7 is 1 only. 1 minus 0 is 1 by
Yes,
7.
ma'am.
Okay, please write it.
Um,
See, Safa, now remember we discussed the trigonometric functions and differentiation. So there's a very easy relation. Differentiation of sine theta gives you positive cos theta. Integration of sine theta will give you negative cos theta. That's the difference.
yes, ma'am.
The differentiation of cos theta gave you minus sine theta. So here the integration of cos theta will give you a positive sine theta. That's it. So here it will be minus, here it will be plus. Whereas in differentiation, this was plus and this was minus. There is again, since we are talking about the limits and all, in integration, it won't be so simple like this. In differentiation, it was very easy. You could just write the values. I hope you're getting this x is some theta, the value of angle.
Yes, ma'am.
See, here you'll have to do one more step. You'll have to put the upper limit, lower limit here also. And for sine also you have to do that. Means, let's say I've taken minus sign outside the bracket. It will be cos of x2 minus cos of x1. Minus will be for both, but I've taken it outside right now to show this. But it will be for
Yes,
both.
ma'am.
Similarly, sine of x2 minus sine of x1. This will be the case of trigonometric function. Okay, and see in exponential function and log function, see exponential was remaining the same in differentiation. Remember,
Yes, ma'am.
differentiating e to
Yes,
the power x remained the same. Here also it
yes,
will
ma'am.
remain the same, but since again we have a problem of limits, so you will have to put in the limits. E to the power x2 minus e to the power x1. This is how you have to put. Okay.
Yes, ma'am.
And if you have, remember when log was given, we used to write 1 by whatever was
Yes, ma'am.
given, 1 by x. If 1 by x is given, you will write it as log. This will be reversed. Again, the same thing.
Yes, ma'am.
Here, one more step will be there, than differentiation, which is substitution of the limits. ln x2 minus ln x1 will, okay?
Yes, ma'am.
Just relate it with differentiation, you'll find it easier. Please write it, Safa.
Yes, ma'am.
Safa, we actually have an eat break for from tomorrow. So if you're available on any day, like Sunday or even on the weekdays, morning or any time, please let me know so that we can have some classes before your test, because you have the test on Thursday, next Thursday. So please
Yes,
tell
ma'am.
me if you are available anytime so we can have a class, 1.5 hour class, more than this 1 hour class we can have.
Yes, ma'am.
So are you available anytime?
Uh, I think the eat break is till when?
Here at Learnivio, we have it till Sunday, but you must be having some Eid break